We would find all our factors of our constant, which is 10. So I'd find, not factors, but factors. My factors of 10 include 1, 2, 5, and 10. Then we have to find our factors of our leading coefficient, but this is pretty nice.
1.
It's just 1. The factors of 1 are just 1. So now we have to take all of these and put them over 1. So I'm going to have 1 over 1, 2 over 1, 5 over 1, 10 over 1. So all of my possible rational zeros are going to be positive, negative, 1 over 1, which is 1, 2 over 1, which is 2, 5 over 1, which is 5, 10 over 1, which is 10. That's it. Those are our possible. Then we're supposed to use our calculator to come up with our exact. Who can give me all of our exact ones? Luke.
-2, 1, and 5.
1 and 5, correct. Which isn't so bad if you know how to plug stuff in your calculator and look at it, right? Now, if you don't have a calculator or don't know how to use it, this problem is a lot harder because now it turns into just guessing and checking. You have to guess 1, -1, 2, -2. Be like, oh, yeah, 1 would have worked. And then maybe you would use synthetic division to get to -2 and 5, possibly. All right, but just know how to use your calculators. It'll make the test easier. All right, any questions on this? Reminder, test corrections are due tomorrow. By the end of the day, I won't be here last period, but you can just throw it in my mailbox if you're done after school. Test is on Thursday, so that means we will have a review in class tomorrow. You guys should already have your review. If you haven't already, pick it up over there. The answers to the review are posted online. I posted them this morning, so everything is good to go for you to get started early. Yeah?
How did we get 5?
That be 10. Any questions for me? Yeah.
This is kind of a side question, but not. Is it difficult to learn everything that you do on this calculator or no? Like, is that, I mean,
No.
like, is there like videos about it? So,
Yes.
Okay.
There's tons of videos on it, and most of it's intuitive.
Okay.
Like you have like a calculate button, you have a math button where all the stuff, you just kind of play around with it.
Okay.
Other questions? Okay, then let's go on to, today should be mostly review and hints on how to do stuff. So I kind of sidestepped this issue when we were doing solving things that were cubic or quartic or anything bigger. Because I basically said, use our rational zero theorem to come up with our possibilities and come up with, through trial and error, or graph it to come up with our answers. There is another method, because I said the only thing we can't do is complete the square and we can't use the quadratic formula. But we can factor certain cubic, quartic, but we're just going to focus on cubic for right now. We can factor this, and it's called factor by grouping. We already did this. If you followed along when I did my factor by grouping, when I did my air conditioning Beyonce columns, we did this exact same thing. And what I want to do is, remember this won't work for all of them. So don't just do this every single time and be like, oh, it didn't work, so I don't have to solve it. This only works for specific ones, and guess what? On the test, if I say solve by factoring, you're going to be able to do this on those. All right? I'm not going to trick you and make you work 10 minutes on a problem that isn't factorable, and then, haha, you wasted time. Gotcha. Factor by grouping consists of being able to turn it into a binomial times a binomial. So that means what we're going to focus on are two binomials. And I'm going to focus on x cubed plus 3x squared, and then I'm going to focus on that plus x plus 3. And what we're going to do with both things that I just boxed in, almost a circle, but I boxed them, is we're going to pull out the greatest common factor out of all of them. So I'm going to factor out that biggest thing I can out of that x cubed plus 3x squared. And what's the biggest thing I can factor out of x cubed and 3x squared? Yes, I can factor out an x squared. So we're going to pull out an x squared. X cubed divided by x squared is just x to the first. Plus 3x squared divided by x squared is just 3. Well, the only thing I can pull out of x and a 3 would be a 1.
But that doesn't make sense.
It does. I'm just going to put it just so I can see that 1 out there. Factor by grouping works when we get this. See that x plus 3 and x plus 3? If those are both the same, factor by grouping worked, and we can continue on. If those two things are not the same, you have to stop and find a new way to solve it. But since both of these are the same, yeah.
Wait, just like that other thing.
Factor by grouping.
Oh, is that the same thing?
It was the same thing.
Yep.
It was the same thing, but it was with the quadratic, right? We did our air conditioning Beyonce column, and we split it apart into 4 things. Well, we started with 4 terms, so it's the same exact thing. Everything's good if it looks like this. If it isn't, I can't go any further. So when we were doing the quadratics, if I came and these were different, you couldn't go any further either. But since these are both the same, we do the exact same thing where we smoosh together that x squared and that at plus 1. So we have x squared plus 1 times x plus 3. We'll check it out. We now have a binomial times a binomial. So either this x squared plus 1 is 0, or this x plus 3 is 0. So we're going to branch those off. So either x squared plus 1 equals 0, or x plus 3 equals 0. If x squared plus 1 equals 0, we're going to have x squared equals a negative 1. I would take the square root of both sides, which would be x squared equals, nope, I'm taking the square root of both sides. So I'll have x equals plus or minus the square root of negative 1. But that just equals plus or minus I. Yes?
So you are not able to factor out the x squared plus 1. Because you could have x plus 1, x minus 1.
I could not. It's not a difference of squares.
Oh, wait, because it's a plus.
It would have to be x squared minus 1. Yep. In which case we would have came up with the same answer. We would have came up plus or minus 1. All right. This last one, we're just going to have x equals negative 3. I was looking for 3 zeros. How did I know I was looking for 3 zeros? Luke?
Your highest exponent is 3.
My highest exponent is 3. I found 3 zeros. I'm good. I got positive and negative I. Just a quick rehasher. If I have positive I as a root, negative I also has to go along for the ride. All right? They always come in conjugate pairs. So anytime you have an imaginary number, you're going to have another imaginary number as well. Always. It is like alternate dimensions. Do the next one. Won't talk.
Is there to access like an imaginary plane on our calculator, or do those not like really exist?
They don't. Yeah. In imagination land.
It's like when our 8th grade science teacher would be like, where do you buy like the magnesium rolls? And he's like, at the magnesium store.
Depends on how you want to look at it.
Oh, it's like the upside down in Stranger Things.
Do you flip or does the world flip? All right. Did everyone get x equals positive or negative I square root of 5 and x equals 2? And then these are the braces, if you want to put it in that form. Either way is fine. Circle them. Make sure I know your answer, because if you're making me find your answer, I'm going to find the wrong one. That's weird. All right, so that's factor by grouping. Awesome. Know it. It'll probably be on the test. All right, the next thing is solving stuff involving square roots. Well, a square root is just like x squared, where you have to isolate it on one side and then square both sides, because the inverse of a square root is square. So I'm going to first isolate my square root of x. So we're going to have square root of x equals x minus 2. So I isolated it. Remember, there's plenty of room for notes if you need to put notes down too. And then I'm going to square both sides. Well, that's going to be x equals, if you need to, just rewrite this as x minus 2 times x minus 2. But however you get there, you should come up with x squared minus 4x plus 4.
Can you go
Can I go further? Yes. We're going to solve it. So I'm going to move that x to the other side. So I'll have 0 equals x squared minus 5x plus 4. Turns out that's factorable.
Oh,
So we're going to have x minus 4, x minus 1, because negative 4 times negative 1 is a positive 4. Negative 4 plus a negative 1 is a negative 5. So that gives us answers of x equals 4 and x equals 1. Yeah, what's wrong?
I have a question. So if we were taking like the cubic root of something, or like if it was like the cubic root of x,
You just cube root cube both sides.
Okay.
Yep.
Yeah. So there'd be 3 solutions then. Still.
Yep. Mhm. But here's where the problem comes in. I'm going to tell you right now,
This is wrong.
this is wrong. Well, this isn't wrong,
Oh. So you were like,
but you wouldn't get full points for this. What was that? We don't have to put in brackets, no.
Positive, negative.
No positive and negatives.
All solutions.
Here's a problem with the square root. Yeah,
Would you have to check your answers when you plug it in, when you have to square both sides?
I have to check both answers
Only one of them.
because we aren't accounting for positive and negatives. Because I'm squaring both sides. Squaring both sides, doing it opposite, they're taking into account positive and negative square root of x. But there is only square root of x. So if there's square roots involved, you have to check your solutions. It does oftentimes give you false positives where you think it's an answer, but it's not. So you have to, for square root problems, plug it back in, make sure it actually works. So let's check 4. So we're going to check both of our answers. We have to. So this is not checking to make sure my work is right. It's to make sure these are actually true answers. So we have the square root of 4 plus 2. Well, square root of 4 is 2 plus 2. It does equal 4. So that one works. When I plug a 1 in, I have square root of 1 plus 2 equals 1. I don't think the square root of 1 plus 2 equals 1. This is not an answer. That's an erroneous solution. It looks like a solution, but it is not. You have to, when there's a square root involved, check both of them. All right, our next one. Note the one before I said we have to isolate the square root, but this time I have 2 square roots. So what we're going to do is we're going to isolate the more complex square root. So in this one, we are going to isolate the more complex square root, which is going to be that square root of 2x plus 1. Once again, we isolate our more complex. So that's square root of 2x plus 1. I move that square root of x to the other side, so we're going to have square root of x plus 1. Once again, this is my most complex one for those of us taking notes. All right, but once we have the more complex one on one side, we still square both sides, which is going to give me 2x plus 1. When I square this, I'm really looking at square root of x plus 1 times square root of x plus 1. Well, that's going to equal square root of x times square root of x is just x. 1 square root of x plus 1 square root of x is 2 square root of x's, and 1 times 1 is 1. Now we have another square root. Yeah.
Oh, never mind. No, I was looking at the last time.
Oh, okay. Now we have another square root, so I'm going to isolate that. I'm going to isolate the 2 square root of x. So that means I'm going to subtract x from both sides. 2x minus x is just x. Negative 1 from both sides, that's just going to get rid of the 1, and we're going to have x equals 2 square root of x. Now you could go one step further and divide both sides by 2, but I'm going to show you why you don't have to. Because if I divide both sides by 2 and square, now I'm squaring a fraction. I'm going to leave it as is. Because when I square both sides, we're going to notice I'm just doing 2 squared and square root of x squared. It's nothing complicated. So we're going to be left with x squared equals, well, 2 squared is just 4x. Working our way down, I have x squared minus 4x equals 0. Whenever I can, I'm going to factor stuff out, if possible. So I have an x squared minus 4x. Rather than plugging that into the quadratic formula, I'm just going to factor out an x to give me x times x minus 4 equals 0, in which case x equals 0 and x equals 4.
So 0 is a solution.
Could be.
It is.
Did you check it?
I did check it.
Oh, does it work?
In my brain.
With your brain?
Yeah, it did work.
Does 4 work? Yeah? They both work. But you should always, anytime it's a square root, plug them in and check them. So I'm going to put a little note that says both work. Because anytime I see a square root, I'm going to say I need to check those answers. All right, but that's stuff involving a square root. Hey, this is all inverses. What's the inverse of a square root? Square. Isolate, square both sides. Then check your answers. All right, moving on. Equations with rational exponents. Once again, I'm just looking. Yeah. Okay.
What happened when you went from 2x plus 1 equals x, like that line, to x equals 2 square root of that?
From here to here?
Yeah.
I just subtracted x from both sides.
But isn't x multiplying on the left side?
And then I subtracted 1 from both sides.
Oh.
I just simplified. I got this x on this side,
Oh.
and I moved this 1 because I was isolating this.
Oh.
But when you subtract 1 from both sides, it just turns to 0.
Yeah.
So I'm just left with x on that side. So it really is just simplifying. All right. Exponents. Once again, we're just doing inverses. What undoes what happened? There's a big gap on top. That's for a reason. We're going to do something in just a second. Well, if I have x to the 4/3, the inverse of that is going to be raising it to the 3/4 power. And why that works is think about exponents and powers. If I have x squared to the 3rd power, you multiply your exponents. It'd be 2 times 3, which would give you 6. Well, if we do the same thing here, 4/3 to the 3/4, 4/3 times 3/4 just equals 1. I get back to x to the 1st. So that would get me back down to x to the 1st, which is what I want. I want to undo it. I want to get x by itself. Oh, I'm not allowed to just do one thing on one side. I have to do it to both sides. So I have 625 to the 3/4 power. And people bringing out your calculators, really good idea. Because I don't know if you know this offhand. But go ahead and plug in 625 to the 3/4 power. Yeah. Yeah, I won. What was that, 125? All right. Here's the problem. Yeah.
How does that work again when you do not have your calculator?
I'll show you. You're probably going to want your calculator for this one. I'll show you what it looks like in just a second. Another way to look at it. Okay, so we have x to the 4/3 equals 625. We don't have our complete solution set, though. Remember when we did x squared, we had to do plus and minus? When I did x cubed, I didn't have to do plus and minus. It just came out to one answer. So what we need to recognize is, you see that 4 there? It's even. An even numerator. If you have an even numerator, you have to use positive and negative. Even numerator means positive and negative. So that would be positive and negative here, which means we're going to have positive and negative here. Let's do a note. Let's do a note to answer what Nick's question was. So if I ever had, say, 625 to the 3/4 power, another way to rewrite this would be a 4th root of 625 cubed. Still hard to do, but a little more feasible because it's stuff that we recognize. All right, and why that happens is, well, 625 to the 1/4 power is a fourth root. It's like 625 to the 1/2 power would be a square root. 1/3 power would be a cube root. And think of this as being 3 over 1 times 1 over 4. So this 3 gets carried to the exponent, the 4 to our root. So just a little side note. I do think some of your answers can be simplified in that fashion. All right, yes?
So, we use like our math button and the X with the radical thingy, this one, when you push it down.
Yeah, if you want to do it that way, yeah.
Okay.
It's much easier just to put it in raised to the fraction. But sometimes it's nice to know how to get from the radical back to the fraction because it's a lot easier in your calculator to actually put in that fraction. All right, so I said if it's even, we use positive and negative. If it's odd, you just have one answer. You don't use positive and negative. So odd means just one answer. Bless you. Either you get a positive or you get a negative out. So we don't have to worry about positive, negative. All right, so we have y minus 2 to the negative 5 over 2. Well, it doesn't matter how complex it looks. Y minus 2 to the negative 5 over 2. To undo that, we're just going to take the reciprocal of our exponent and raise it to that. So it'd be negative 2 over 5. Because negative 5 over 2 times negative 2 over 5 will be a positive 1. That would be a positive 1. Well, that's just going to equal 32 raised to the negative 2 over 5. So I have y minus 2 equals, yes? 0.25. I'm just going to leave it as a quarter. A nice little quota. Now we're going to add 2 to both sides, which would be 9 over 4.
And it's just that because it's odd.
Because it's an odd. And we look at the first one. Don't wait till you flip it and then look at it. Always look at the original. If it's odd, one answer. If it's even, plus or minus. All right, questions? Okay. We're going to solve absolute values now. We've already done this. The first one is very similar to one we've already done. Remember, whatever's in here has to equal 8 at the end of the day. Absolute value of 8 equals 8. Absolute value of negative 8 also equals 8. So everything inside here can equal 8 or negative 8, and it's still going to work. So that means we have to set up two equations. We have to have x squared minus 2x minus 16 equals 8. Or we're going to need x squared minus 2x minus 16 equals a negative 8. Then we just solve both of them. So the first one, I subtract 8 from both sides, which gives me x squared minus 2x minus 24 equals 0. This should be factorable. Can anyone get the factors for that? I got to get the x's for you. I did the hard part. Aaron.
X minus 6 times x plus 4.
Plus 4. So you're saying negative 6 times 4 equals negative 24? And then you're saying negative 6 plus 4 equals negative 2? I agree. You're right.
Okay.
Just so you.
Don't do that.
You made it seem like you're wrong.
All right, so we have x equals
Yes, that's pretty.
and we have x equals negative 4. Let's do the next one. So we have x squared minus 2x. We're adding 8 this time. So we're going to have minus 8 equals 0. This one is also factorable, thankfully. Who can give me this one? Jack.
X minus 4 and x plus 2.
So you're saying negative 4 times 2 is a negative 8. And negative 4 plus 2 equals negative 2?
I couldn't say it better myself.
All right.
Because it's too confusing for me to say.
Okay. So x equals 4. and x equals negative 2. And those are all our answers. And you could check them. They'll work. All 4 of them will work. But the next one is a special problem. It's you. Yes. You should always check. These will always work as long as your math is correct, but it's always good to check. This one can fail even though you did everything correct. And you'll see what's special about it. So note this one says it's equal to 8. Yeah.
Oh, I was going to say something about the next one.
Okay. What's different about the next one?
Well, you can only have it where x is positive.
Why can x only be positive?
Because you can't have an absolute value and get a negative number.
Absolute value of this has to equal 5x. Can an absolute value ever be negative?
No.
No. So that means that 5x has to be positive.
And if it was negative 5x, it would have to be negative.
Yes, yes. So that has to be positive. So x must be positive. So x must be greater than or equal to 0 for that to work. So as we're going through this, we have to think about that. If x is ever negative, that's a problem. That's not a real solution. And it's going to happen. All right, other than that, we're going to solve it the same way we did the other one. We're going to say either x squared minus 6 equals a positive 5x, or x squared minus 6 equals a negative 5x. And then we're just going to solve both of them. So on this one, we're going to have x squared minus 5x minus 6 equals 0. Can someone factor that for me?
X minus 6x plus 1.
So what you're saying, no, that's right. That is correct. So we have either x equals 6 or x equals negative 1. Are we okay with x being negative 1?
No.
Why not?
Because it can't be negative.
It can't be negative. We already said x has to be bigger than or equal to 0, because if I'd plug this in, we'd have negative 5. Absolute value can't equal negative 5, so this doesn't work. X equals negative 1 doesn't work. All right, let's do the next one. So we have x squared plus 5x minus 6 equals 0. Can someone factor this for me? I don't like doing the hard work. Nick?
X plus 6 times x minus 1.
Perfect. So either x equals a negative 6. Is it allowed to equal negative 6? No, it's not. So that one's gone. And we just have x equals 1. So we really only have two answers. X equals 6, x equals 1. Because the negative ones, if I plug it back in, won't work. So, who asked, do I need to check if it's... So if it's absolute value, over here it should work every single time, but this one you should definitely check, because it will give you wrong answers.
Just because there's a variable
On the other side.
Okay.
Yep. All right, that leads us to the last special case. Our last special case is what happens when I have absolute value bars on both sides. It really isn't that special. It's just, you got to think about it for a second. Let's say a minus 1 equals 2.
They both have to be positive. No. No, they can neither. I don't know, man.
Let's say a minus 1 equals 2. And 2a minus 3 also equals 2. Does that work? Does the absolute value of 2 equal absolute value of 2? Yeah. What if this one's 2 and this one's negative 2? Does that work?
Yeah.
Does it work if this is negative 2 and this is positive 2?
Yes.
Would this work if this is negative 2 and negative 2?
Yeah.
So we have two things that could happen. Either they're exactly the same number, like 2 and 2, or they're opposites of each other, and one's positive 2 and one's a negative 2. So either a minus 1 and 2a minus 3 have the same value, or they are opposites. To check that, you just got to say, well, first let's check to see if they're the exact same value. A minus 1 equals 2a minus 3. The other possibility is that they're opposites, in which case we just have to check a minus 1 equals a negative quantity, 2a minus 3. And you could have, if you wanted to, you could have put this negative sign over on this one. So the negative version of a minus 1 equals a positive 2a minus 3. You just got to make one of them negative to show that they're opposites. All right, if they're the same value, we have this one. I guess I'm going to subtract a from both sides and then add 3 to both sides, which would be 2 equals a for that one, solving it. This one, we're going to have a minus 1 equals a negative 2a plus 3. Ooh, did I make a mistake already? On which one?
It should be -2.
No, it should be 4.
Wait, what? Okay, then I'm wrong. It should be
Isn't it 4? Wait.
No, it's fine. Let's go through the steps.
No, because there's.
Right.
So,
Oh,
so
never mind, never
if
mind.
I subtract a from both sides, I would end up with a on this side.
Oh.
And if I add 3 to both sides, I would end up with 2 over here. So we have 2 equals a, or a equals 2. Cool. All right, our next one. I would add 2a to both sides. That would give me that 3a, but I should also, let's do the same step. Let's add 1 to both sides. This one does equal 4, and we have a equals 4 over 3, and both those answers will work in there. But it never hurts to check. Real quick, it was a lot of information, but hopefully most of it was review and just kind of special situations. Yeah,
Will they ever not work? They can't be negative, right?
correct. These will always work as long as you do it correct. As long as you do these correct, these will work.
So
The
could
the
you
big
get a
ones,
negative number for that or no?
you could get negative numbers. Yeah, yep. So this one would work as long as you did the math correct most of the time. The ones we're really focusing on not working are if there's an absolute value bar and a variable on the other side, and whenever square roots are involved, would be times to really concern yourself with it actually working when you plug it back in. All right, homework due tomorrow. You guys have the reviews. I will check your reviews at the end of the class tomorrow, so if you don't want to have to turn it in the next day, then make sure it's done or mostly done tomorrow. Test is on Thursday. Yes, Jack.
Is tomorrow going to be a work day?
Tomorrow will be a work day for the review.